welcome to Leo's channel. Let's do some Leetcode today. So this question is a binary tree longest consecutive sequence. So now we were given the root of a binary tree, return the length of the longest consecutive sequence path. What does it mean by consecutive sequence path? So a consecutive sequence path is a path where the values increase by 1 along the path. As we can see here, the longest consecutive sequence path is this, 3, 4, 5. Let's take a look at this node. This node is 2, so this will make a 2, 3, 4, 5. But in this case, you can start at any node in the tree, and you cannot go from a node to its parent in the path. So that's why it doesn't count this 2 in it. All right, so this is a pretty normal tree traversal problem. So let's take a look at this. Given this tree, the longest consecutive path, increasing path, is this. And this one, since it can only come from the root pair of the parent to the children, so this is the longest increasing path instead of this 1, 2, 3. Okay, so how do we approach this? So first we need to traverse the tree, right? And typically we're thinking of a recursion solution. So let's think about what do we need to do at each node. So first, let's do some sanity check. If root equals to null, then return 0 because there's no consecutive sequence path, since there's no node in it. And we need a global max to record the longest consecutive sequence path. So since we only need one integer number, I'm going to use an integer array to record it. Mean value, okay? And also during the way, I'm going to do a recursion function. I'm going to call it helper. So we will get the tree in it and update the global max. Then we'll return the number in the max integer array. Okay, so now how do we write the recursive function? So we are going to return the integer, and what are we going to return? We're going to return the consecutive sequence, longest consecutive sequence path of the current node. Okay, so of each node, say for this node, the longest consecutive sequence path that it returned is 4, 5, which is 2. Okay, and when it returned at this node, the node who caused this recursive function, it will add the maximum of this path to itself. Okay, and this is going to be the tree node root, and it's going to have the integer array max. So first sanity check, if root equals to null, return 0. Okay, and for the recursive function, we're going to make a left, which calls the helper function for the left subtree, and we're going to have a variable that calls the right subtree. Okay, so this left subtree gives us the longest consecutive sequence path for the left side, and the right gives us the right side. Okay, so what do we do now? We're here at this node, the current node. We are going to update whether it is a valid path from here, right? So let's see, left max equals to, if root dot left doesn't equal to null, which means there's a left subtree, and the root dot left dot value equals to root dot value, let's see, +1, right? if this is the truth, that means we can connect this node to the subtree. So that's left plus 1, else there will be only this one node, okay, for the longest consecutive sequence path. So the same thing works for the right subtree. So if the right subtree is null, root of right of value equals to root of value plus 1. Is it right? If it's right, update it, then no. Okay. So that's what we need to do now. Okay. Now we have the longest consecutive sequence path. We can update the max, which is max 0, and what else? Since we cannot go through the current node, right? We cannot form something like this. We can only take the value from either side. So we're going to use the maximum of the left max and the right max. Okay. And we're going to return what? We're just going to return which is the longest path to take. Okay. All right, now here. Okay, this should be it. And the time complexity and space complexity should be n, where n is the total number of nodes. And with the space complexity, the worst case, there are n nodes in the stack. Okay, so let's try this. Yeah, it worked fine. And does it pass? Okay. I'll see you next time. Thank you for watching.